Hello and welcome to class number 18. We're going to finish chapter 9 on replacement analysis. This will cover sections 9.32 through 9.4, and it will cover pages 286 through 290. That'll leave us enough time to work several problems in chapter 9, and additionally two of the problems are actually homework problems, so that should help you somewhat. So the first section, 9.32, deals with when the study period is specified. So you're looking at a specific time frame, and over that time frame you want to find which alternative is best. Again, we're probably the only two alternatives we're looking at is the defender and simply the best challenger. So that's what this chapter is about. And the section 9.4 is deals with problems where the defender's replacement value, which is called RV, is defined as the minimum current value for the defender at which the challenger becomes the better alternative. So if the defender costs more than this, then the challenger, or this amount, then the challenger is going to overtake it and be the better choice. So we call that value RV, the defender replacement value. And so when we have this type of a problem, we let the present value of the defender, P sub D, be a variable. And then we find the value at which the annual worth of the challenger equals the annual worth of the defender. So the process is let the defender's current market value be P sub D, a variable, and then set the annual worth of the defender equal to the annual worth of the challenger, or the minimum annual worth of the defender equal to the minimum or economic service life of the challenger, and solve that for P sub D. So let's work on some problems. The first problem states the following, and the problem is quite a bit longer than the answer, but we'll read through it and work through it as we read it, so to speak. Newport Corporation purchased equipment for making pneumatic vibration isolators at a cost of $90,000 2 years ago. Remember, I said what something cost before has no bearing on the problem unless it tells us something about what it'll cost or what its market value will be. And in this case it does. He says it has a market value that can be described by the relationship 90,000, which was what you paid for it, minus 8,000 K, where K is the number of years. So the market value now, for example, the P for this this asset right now will be equal to its current market value, but this is 2 years from when it was first put into place, which is 90,000 minus 8,000 times K, which is the age of the machine. It now is the time is 0, but K is already 2 because we bought that machine 2 years ago. When of course that's 16,000 from 90,000 will leave us with 74,000. as its current market value. Then the author goes on. He says, experience with this type of equipment has shown that the operating cost for the first 4 years is $65,000. So I'll just say AOC for 1 through 4. Well, actually, we're going to be into year 3 here, is equal to $65,000. Okay, and that's dollars per year, whereas this is just dollars. Okay, and so after year 4, starting in year 5, it goes up by a constant amount, which is G equals $6,300 per year, starting in year 5. Okay. The asset has a salvage value that was originally estimated to be $7,000 after its predicted life of 10 years. So originally the salvage value S10, so you could say S10, was $7,000, but now it's still the same, but it's 8 years from now, $7,000. And that's a plus, whereas all these others are minus. The author says then determine the values of PSN and AOC if a replacement study is to be done now. So we're thinking about replacing this now. What's the present value of the system? Well, we found that out. That's part A for now. The present worth of the asset is essentially, or the present cost, you'd say, $74,000. And the answer key is not real consistent on pluses and minuses. I would think this should be minus 74, but that's probably not one of your choices for an answer. So I would try minus 74, and if it didn't work, then I try plus 74 because that's the number. Okay, so then the next thing it wants is the salvage value. Well, the salvage value is still $7,000. This is dollars per. This is dollars, and the salvage value S is $7,000, and the annual operating cost is let's see, it was going to be for the first 4 years $65,000, $65,000 per year. So this is the answer to part A. And for part B, it says, what if you're going to be looking at it 1 year from now? Well, what's the market value of the machine then? Well, it would be 90,000 minus K times 3. So it'll be 74,000 minus 8,000, which would be $66,000. So at that time, P would be equal to 66,000. And that's just dollars. And the salvage value is still 7,000. That didn't change. I'm sorry, I got that wrong. It's not 7,000. The salvage value, if you just at the end of 1 year, this S, if you looked at just keeping it 1 year, the salvage value would be the market value where K is equal to 3. So this is going to be 66,000. And so the salvage value will be the market value. So S will be equal to MV at time 4, which would be, because this is just keeping it one more year, this would be 66 minus 8. When K is equal to 4, this is 32. We're subtracting that from 90. We get $58,000. And finally, the AOC is still 65. Of course, the AOC now will start to change after starting in year 5. Okay, but we're only looking at it for 1 year at a time here. So that is basically the answer to problem 9.4. The next problem to look at is pretty complicated. Leroy, and this is a homework problem, by the way, an AI robotic system with a first cost of $345,000 and an annual operating cost of $148,000 per year, and a salvage value of $8,000 over its economic service life, which is 3 years. So let's draw that up. Let's see, I'll just put it here. We're going to pay $345,000. The salvage value after 3 years, 1, 2, 3, will be $140,000. Those two are the components of the annual cost of capital recovery. And then we will have operating costs of $148,000 per year, which is a uniform series. So that's the cash flow. Then he says, rather than trading after 3 years, he kept the system for a total of 5 years. Due to the wear factor and expenses of repairs, the annual operating costs increased to $240,000 per year in year 4, plus the salvage value went to 0 at an interest rate of 10%. What is the percentage increase in the annual operating cost or annual worth of the machine? So let's start by getting the annual worth if K equals 3. Okay, well that would be equal to take this $345,000 and spread it over the 3 years forward, A given P. So this would be $345,000. A given P. The rate is 10% for 3 years. This is a uniform series, and that's 148,000. And since all of these are costs, I'll just put a negative sign here. Then I have minus 148. That is a uniform series. That's dollars per year. Now this is dollars here, but once we multiply it times A given P, it spreads it over the 3 years. This is going to be dollars per year then also. And then we have this future value. So we need to take this future value or salvage value and spread it backwards. And to do that, we do A given F, and of course it has a plus sign. So that would be plus 140. That's essentially a future value times A given F, 10% for 3 periods. So that is the value of the annual worth of keeping it 3 years. So AWK equals 3 would be equal to that quantity, which if you work that out, it comes out minus $244,434. So now let's see what happens if we keep it 5 years and our annual cost for operations goes up to $240,000. Now, so this is the 3-year analysis. Now we're going to do what happens at 5 years. Well, I'm not going to redraw the diagram. I'll just put in what happens as we add 2 more years to this, okay? Well, you add years 4 and 5, and you have 240 here and 240 here. And your salvage value, he says, goes to 0. So we take that out and put a 0 here, okay? And so this is the cash flow for 5 years. So we've got to somehow make that into a uniform series to compare it with this one. So I'm going to say the annual worth from years 1 through 5 of this, K equal 5, will be equal to the following. Well, what we're going to do then is take this 340,000 and spread it over 5 years instead of 3 years. So that's going to kind of spread it thinner, so that number is going to be smaller, a given P, 10% for 5 years. Then we've got this number, minus 240. Well, if we take our 140 that is only there for 3 years, so minus 148,000, bring that back to the present time, P given F, 10% for 3 years, that's the present worth of that A series. Then I can spread that over 5 years, so I'll do the same thing I did here, A given P, 10% for 5 years. That takes these 3 values back to the present and then spreads them out over the 5 years. Finally, we've got this 240, which is another little uniform series. So it's minus 240,000. But that series only is 2 of them. So we'll do P given A, 10% for 2 periods. Now, where's this money? Where is that quantity once we do the P given A? It's right here. It's at the end of year 3. How do I take money from year 3 back to year 0? As a single amount, P given F, 10 and 3. Now we have, once we do this quantity here is at time 0. We want to spread it over 5 years. A given P, 10 and 5. So we do all these calculations, and you'll see that the result is the annual worth of 1 through 5 years, K equal 5, is equal to minus 270,656, which of course this costs more than that. This is the higher value, so this would be selected. So the conclusion would be the cost increases to go beyond 3 years on an annual basis. And in fact, in the second part of the question, he asked, what is the percentage increase? Okay, so what's the percentage increase of this over this? Okay, so percent increase in annual worth or annual cost is equal to. So we would take this minus this divided by that times 100%. So it'll be your base value, which is in the denominator, 244, 434. This will be 270, 656 minus 244, 434. And then I take that and multiply it times 100% because that's going to give me a fraction. If you do that, you end up getting actually the fraction itself would be 0.1073, and then when you multiply it times 100%, you'll get that equal to 10.7%. 10.73, I guess, percent if you want to carry the decimal place there. So that is problem 7.10, which again is one of your homework problems. The next problem I'm going to look at is number 13 in chapter 9. And it says, based on company records of similar equipment, a consulting aerospace engineer at Aero Patel, whatever, estimated annual worth values for a presently owned highly accurate steel rivet inserter as shown. Okay, so he's looking at if retained this number of years, 1, 2, 3, 4, 5, the annual worth is, if you keep it 1 year, it's minus 62,000 a year, 2 years minus 51, 3 years it's minus 49, 4 years it's minus 53, and 5 years minus 70. So which is the best? Well, obviously, this is the best. This would be the economic service life. Is 3 years, and the annual worth would be minus $49,000. Now, the author then says the Challenger has an economic service life of 2 years and an annual worth of minus 48,000. So annual worth of the Challenger at ESL equals 2 is minus $48,000. So which is better? This is the Defender. That's annual worth of the Defender at its ESL of 3 is 49. This is 48. It's pretty close, but this is better. Okay, so this would say choose the Challenger. Okay. The author then says that the MAR is 15% a year. We didn't even need that yet. Okay. If the consultant must recommend a replacement decision today, should the company keep the Defender or the Challenger, or purchase the Challenger? So the decision is to purchase the Challenger. Why? Well, it has a lower annual cost. Okay. So that's part A. Choose the Challenger because annual worth of the Challenger is less than annual worth of the Defender. Part B says, when should the next replacement evaluation take place? Well, remember, the Challenger has an economic service life of 2 years, so I would say 2 years from now. And under what assumptions? Assuming the estimates do not change. Now, certainly they might change a little, but we're talking about significant changes. Suppose after the first year of operation, we figured out that this Challenger actually cost twice as much as we thought it was going to cost. Well, certainly we would look at then, remember, once you choose a Challenger and you put it in service, from then on it's a Defender. And so we would look at any Challengers that that Defender had, if in fact it was not living up to its promise of $48,000 a year for operations. So we'll do another problem, problem 922, and that problem is also a homework problem. And it says a machine purchased 3 years ago for $140,000. Again, kind of irrelevant information, depends on what it's worth now that's relevant, is currently too slow to satisfy increased demand. Okay, so it is not going to be able to be used like it is. The machine can be upgraded for $70,000 or sold to a smaller company for $40,000. Now, if you keep this machine, then you're foregoing $40,000 in revenue and you're spending $70,000 in cost. So the cost to you is really $110,000, because this is the current market value, which is what we said is the present value of the current machine. But to make it do what we want it to do is going to cost $70,000. So the present worth of the Defender is going to be the $70,000 that we have to spend to upgrade it, plus a minus $40,000 because we gave up receiving that $40,000, which we would have received if we had replaced it. So both of those add up to minus $110,000. Okay. The current machine will have an annual operating cost of $85,000 a year and a salvage value of $30,000 in 3 years. So AOC, he didn't say over what years, but I'll assume that's years 1 through 3, of minus $85,000 per year. These are just dollars here, not per year. And then the salvage value, call it S3 of the Defender, this is of the Defender also, is plus $30,000. And this is just dollars. Okay. If retained for 3 more years, okay, all of that, the replacement value will serve the company now and for at least 8 years. Okay. So that's the Challenger. So let's see what the deal on the Challenger is. It will cost $220,000. So P Challenger is minus $220,000. We'll have a salvage value of $50,000 for years 1 through 5. And then he says it'll be $20,000 after year 6. So S6 is $20,000. And then he says $10,000 thereafter. So since we're looking at up to 8 years, 7 equals 8 equals $10,000. So that's the salvage value function for this particular asset. The company has a MAR of 15%, and we have a 3-year planning horizon. This is key. So when you're given a specific study period, everything has to be done for that number of years. Should the company replace the presently owned machine now or do it 3 years from now? What are the annual worth values? So let's look at what happens if we keep it for 3 more years. Okay, so the annual worth of the Defender for n equals 3 is, it cost you $110,000 to keep it, A given P, 15% for 3 years. It costs you $85,000 a year to operate. This is dollars per year. This is dollars, but when we spread it out over 3 years, it becomes dollars per year as well. And then we have the salvage value at time 3. So I'll have plus 30,000, A given F, 15% and 3 periods. So when I work through all of that, I will get minus 124,538. And that's going to be dollars per year, of course. Okay, that's the annual worth if I keep the Defender 3 more years. So now I'll look at the Challenger. Annual worth of the Challenger for 3 years of service will be cost $220,000, spread that over 3 years, A given P, 10 and 3. And let's see, there must be an operating cost for that thing that I didn't put down. Salvage value, there it is, $65,000 operating cost. So I need to write that here. AOC will be equal to minus $65,000, and that's dollars per year, minus $65,000 per year. And then we have a salvage value at the end of year 3 of $50,000, because it's $50,000 anytime up to year 5. So that'll be plus $50,000. A given F, 15 and 3. And if you crank through all of that, you'll get that the annual worth of the Challenger is minus 146,957, and that's going to be dollars per year. So we're comparing this number to annual worth of the Challenger at 3 years. That's our study period. And we get the annual worth of the Defender is less than the annual worth of the Challenger. So keep the Defender is, should the company replace the presently owned machine now or in 3 years? Keep it. What are the annual worth values? Minus 124,538 and minus 146,957, and that completes this particular problem, and that completes this particular problem session. So thank you, and good luck with those homework problems.